Okay, so in this video, we're going to evaluate this limit right over here. So before we evaluate it analytically, first we're going to find the answer by approximating it. Okay, and one way we can do that is by noticing that we're taking the limit as x approaches negative infinity, right? So in other words, we're looking at the behavior of this function as x gets really, really big and really, really big negative number, okay? So as an example, we can set x to equal to some really, really big negative number. So let's say negative 9,999. Okay, and then we'll see what this expression will, the function will evaluate to when we plug in this x. Right, so we can do that here. It would be negative 9,999 to the power of 2 plus 15 times negative 9,999 minus 15. All of this is square rooted. And then lastly, we have plus negative 9,999. Okay, and we can plug this into a calculator here, and let's see what result we get. So the answer we get is approximately negative 7.50356, and then there's more digits that I'm ignoring. So we can kind of guess that the answer should be negative 7.5 because this number is very close to that. And we can imagine if we would increase our number here, right? If we would make it, larger in magnitude, maybe negative, 9 million instead, that would get closer and closer to make this 7.5, right? So this is the answer that we're looking for. But on an exam, this method wouldn't fly. Maybe you only get a couple of marks. Usually, if they give you a question like this, they want you to solve it analytically, not by approximating. Okay, so we'll keep this answer in mind. We'll put this on the side here, negative 7.5. But we will solve this problem analytically using algebra and properties of limits, and we should, at the end, get this answer. So let's solve this problem analytically. So the first step we're going to do is we're going to want to put this in fraction form. Okay, we kind of want to transform this expression into a fraction. And the way we're going to do that is by rationalizing the numerator. Okay. So I'm going to rewrite the limit as x approaches negative infinity. I'm going to rewrite this expression. I'm going to write this all over to fraction 1. And I'm going to multiply it by this fraction by 1. Okay, and I'm going to multiply it by 1 in a very clever way. I'm going to multiply it as follows. Square root x squared plus 15x minus 15. All this is under the square root minus x. And I'm going to do the same thing on the denominator to make sure that I'm multiplying by 1. Okay. So you might be familiar with this technique. This is rationalizing the numerator. And note that I changed the signs here, right? So I'm multiplying by the conjugate, the numerator and denominator by the conjugate expression here. So now I'm going to multiply it out. Right, so I'm going to write this on a new line. So I'm going to have x squared plus 15x minus 15 minus x squared. All of this is going to be divided by the square root of x squared plus 15x minus 15 all over then minus x. So all I did was I took the numerator, I took this top expression here, multiplied it with this. Notice that this is just a difference of squares. So we apply the formula, we simplify to this. If you're not familiar with that formula, you can just FOIL it out and you'll get, after you do some simplification, you should get this. Right, and in the numerator, I just do the denominator. I just did 1 times this expression and I put it right over here. Great. So now we transformed our expression, our original expression, right, into kind of like a fraction form. So they're equivalent, they're the exact same, but now we have a fraction, okay? And now we can use the techniques to evaluate limits like this that we discussed in previous questions, and the same techniques will work. Okay. So what's next? So something I kind of noticed right away is that one, these brackets up here are not necessary. We can erase them because it's just terms being added and subtracted from each other. Also notice that the x squared and this x squared will cancel each other out. And we can maybe rewrite this. So we have 15x minus 15 in the numerator, and then we still have the same in the denominator. Okay. Now, what we want to do is we want to factor out the highest power inside the denominator. Okay, we're going to do it in kind of some clever ways. Okay, so I'm going to write a little aside here. So I'll call it scratch work. I'm going to call it scratch work. So notice the following. Okay, we have our, I'm going to rewrite the denominator. Well, specifically the radical, the square roots. So the x squared plus 15, x minus 15. And I'm going to do some algebra work. So I'm going to factor out inside the radical, I'm going to factor out the x squared. This is the same thing as x squared times 1 plus 15 over x minus 15 over x squared. So all I did was I factored out the x squared. Then I'm going to use the property that a times b under the radical is the same thing as square root of a times square root of b. Okay, so I'm going to apply that. I'm going to apply that here. this will be the same thing as the square root of x squared times the square root of 1 plus 15x minus 15 over x squared. Okay, and then the last step here is we're going to use one of the definitions of absolute value, namely the absolute value of x is equal to the square root of x squared. Okay, this should make intuitive sense. Why? Because the square root will cancel out with the x squared, and we know that whatever's inside the square root has to be positive, right? And that's kind of what the absolute value of x is, right? It has to be positive. So I'm going to rewrite this as absolute value of x times the square root of 1 plus 15x minus 15x squared. Okay, so we did our scratch work. So now I'm going to take what we just discovered here, what we just found out here, and plug it back into our equation. I'm just going to erase now. So this limit now becomes the limit as x approaches negative infinity of, I'm going to still keep the numerator as is, but the denominator now is going to be absolute value of x square root of 1 plus 15 over x plus 15 over x squared. And we can't forget the minus x of it. So now we have this expression here. Now we want to deal with the absolute value of x. Okay, we want to deal with this. So how do we deal with this? Well, recall that we're evaluating the limit as x approaches negative infinity, right? So we're looking at very, very negative values of x. Okay, so what we can do is we can restrict the domain. Okay, we can say domain is now I don't know, let's say negative infinity and 0, not including 0. Okay, this shouldn't really matter that we're restricting. It shouldn't change anything because we're looking at the x value as approaches really, really big negative numbers, right? So like what, negative a billion, negative 10 billion to the power of 10, you know, really, really big negative numbers. So we don't care about what's happening in the positive numbers, right? So we can basically just ignore it, okay? And what that allows us to do is change the absolute value of x to negative x. Okay, so we can change this absolute value of x to negative x. Okay, why? Just recall the definition of what absolute value is, right? Absolute value of x is equal to negative x if x is less than 0. And x if x is equal to or greater than 0. Notice that since we restricted our domain, right, we're only looking at really negative numbers, right? Only this is applicable, right? So whenever we have an absolute value of x, we can basically just replace it with negative x because we're only looking at negative values of negative values of x, basically. Okay. Okay, so now we have this expression, and now we can do some, a little bit more algebra. So now I'm going to write the limit as x approaches negative infinity And now I'm going to just recopy the numerator. And now I'm going to factor the x, the negative x. I'm going to factor out the negative x, right? So this becomes negative x. And then in brackets, we have the square root. That doesn't change. And then we have minus, well, plus 1, right? Because we factor out the negative 1. So it's going to be a plus 1 there. Okay. Something else we can do is we can factor out the power of x, right? Sorry, well, we can factor out the x in the numerator, right? So we can pull out an x here. And then what's inside, we just divide by x to balance it out. So this will become 15, oh, sorry, excuse me, just 15, and then minus 15 over x. And the reason we do this is that now we can cancel the x's, okay? We can say, okay, look, this x up here is negative x, we will cancel that, okay? Note that this minus does not cancel, right? So this minus still stays, but the x's are gone. So I'm going to rewrite this now. Limit as x approaches negative infinity. And then we have in the numerator 15 minus x over x divided by negative. And then we're going to have the square root of 1 plus 15 over x plus 15 over x squared plus 1. And this is all kind of like in brackets. Okay. Now we can apply the limit. Okay, we can go ahead and apply the limit. So we can say, hey, look, we have 15 divided by x. That number as x approaches negative infinity, that's just 0. So this here becomes 0. Same idea with these guys down here. 15 divided by x, that will just approach 0. 15 divided by x squared, that will approach 0 as well. Okay, so when we evaluate the limits, what we get left with is 15 in the numerator and divided by negative, right? Don't forget the negative. Negative square root of 1. Right, just 1, because all these are 0, so it's 1 plus 0 plus 0. That's just 1. Sorry, there's a bracket here. Plus 1. Right? And this gets us 15 in the numerator, negative in the denominator, and then square root of 1 is just 1. Plus 1, so that's 2. So we have 15 divided by negative 2. And this simplifies to negative 7.5. And notice that this is the same answer that we got by approximating the answer, right? By plugging in very big negative values of x into our original equation. So this is the analytical solution, right? This is showing all our steps, showing exactly what the answer is. It's much easier and faster just to approximate it. And 9 out of 10 times you will get the right answer. Okay, not always, but almost always you will get the right answer. But usually if you get a question like this on the test, it means that they want you to go through all the steps.